I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a world where your smartphone, your laptop, and even the computers in fighter jets or satellites aren't just faster. They're smarter, more efficient, and more capable than ever before. For decades, Moore's law, the idea that the number of transistors on a chip doubles roughly every 2 years, has fueled this explosive growth. But we're reaching the limits of simply making chips smaller. To keep pushing the boundaries, engineers are turning to a new approach, stacking and stitching chips together in 3 dimensions. This is called 3D Heterogeneous Integration, or 3DHI, and it could transform computing for defense, AI, and high-performance systems. Leading this effort in the U.S. is DARPA's Next Generation Microelectronics Manufacturing Program, or NGMM. NGMM is building the first national pilot line for 3DHI microsystems, a high-tech accelerator where researchers, startups, and even defense contractors can experiment, iterate, and bring designs to life without spending billions on their own fabrication facilities. It's DARPA's way of creating a domestic hub for cutting-edge chip innovation critical for defense, AI, and high-performance computing. So what exactly is 3DHI? Instead of cramming everything onto a single giant piece of silicon, 3DHI lets engineers combine multiple specialized chips, processors, memory, sensors, even photonics into a single compact system. Imagine building a skyscraper instead of a sprawling warehouse. More capability in the same footprint with everything connected efficiently. One key component is the interposer. Picture it as an internal highway system inside the chip, linking all the components together so processors, memory, and sensors can communicate seamlessly. To connect the layers vertically, engineers use through-silicon vias, tiny vertical holes filled with conductive material. These act like elevator shafts inside the chip, letting signals travel up and down at lightning speed. With interposers and these elevator shafts, a stack of chips becomes a unified high-performance system. The advantages are enormous. 3DHI doesn't just save space, it cuts power consumption, increases bandwidth, and allows engineers to mix and match the best chip for each function: logic, memory, RF, or photonics, all working side by side in perfect harmony. The potential applications are huge. Imagine next-generation fighter jets and missile defense systems that demand fast, efficient onboard computing. Or satellites and space systems where size, weight, and power are always at a premium. 3DHI could unlock entirely new missions. But there's a challenge. The U.S. currently lacks a centralized, open-access facility for designing, prototyping, and testing these advanced microsystems. Startups, universities, and even defense contractors often rely on foreign foundries, which slows innovation and raises security concerns. DARPA's NGMM program addresses this directly by creating a trusted domestic ecosystem for advanced chip packaging, from novel materials and chiplets to design tools and thermal solutions. DARPA's NGMM program also supports a broad array of emerging semiconductor technologies. Compound semiconductors for high-frequency communications, photonic devices for ultra-fast interconnects, novel memory architectures designed for advanced computing, and wide-bandgap or ultra-wide-bandgap semiconductors. Think of them like reinforced highways that carry heavy-duty signals safely without breaking down. These materials are critical for next-generation power electronics and high-voltage defense applications. If successful, NGMM will dramatically shorten the path from lab to mission-ready hardware while keeping supply chains secure. The bottom line is 3DHI isn't just another incremental improvement in chips, it's a paradigm shift. By enabling modular, mix-and-match chip systems, supported by DARPA's pilot line, the U.S. can maintain leadership in defense electronics, secure computing, and beyond. So the next time you hear about microchips, remember the future isn't flat. Moore's law may be slowing down, but stacked, connected 3D systems powered by programs like DARPA's NGMM are ready to deliver smarter, faster, and more capable technology from the battlefield to space and everywhere in between. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.